Hi guys, and welcome back once again to Modeling with RFEM 5. In the last few tutorials, we covered different types of beam structures like frames or trusses, and today we will focus on cable structures, what's special about them, but more importantly, how we can design and analyze them correctly in RFEM. So the reason what makes cables special from a structural engineering view is that cables are only able to be stressed to tension, and in case of compression, they will fail immediately. In RFEM, this behavior is considered by the member type cable, which should only be applied if the deformations have a significant influence on the change of internal forces, so only if large deformations can actually occur. The reason for that is because cables are not calculated according to the second order analysis, also called P delta, but according to the large deformation analysis, which is also known as the theory of third order. Since this calculation is an iterative calculation, the results are reached by an approximation, and with an approximation, the probably most exact solution can be found. But this involves also the largest calculation effort. So if you have, for example, bracings, it's better to choose tension as member type instead of a cable. Apart from that, we have also the add-on module RF shape finding, and with that we can set, for example, the cable absolute sag, which we will do for our example later. So much to some theoretical aspects, and now we will start modeling our structure. So we can see here the dialog for the general data, and here we have to define a few more settings than usual. First, we will select instead of a 2D model, a 3D model. Then we have to activate RF form finding, which we can find under options, and then click on this checkbox here. Then we can close this dialog by clicking OK. And our example will be a mast with 4 cables. We will start with creating the mast. For that, we will choose up here in the toolbar new member, and as cross-section we can set, let's say, a rolled cross-section, this one here. The material we can keep steel. Our mast will consist 2 parts or 2 members. The first one will be 10 meters and the second one will have a height of 8 meters, so in total we have a height of 18. For an easy way to create the member, we can change up here the work plane to this XZ plane. And the first node of our first member will begin here in the origin, up to 10, then the second one with a length of 8 meters. Now we can switch back to the XY plane, and next we will create the cables. For that, we click here on new member again. And as mentioned in the beginning of this video, we will set the member type to a cable member. Then we can open up the cross-section library once again and choose a cross-section. We will choose a solid section, and under filters on the left side, we can choose a cross-section according to any standards. And we can also find, according to the cross-section type, cables. We will choose, for example, fiber, this one here, cable PE15. Now we can click OK through all of these dialogues. We will place the first cable starting from the middle node down here to the point with the coordinates X 4.243, Y 4.243, and Z will be 0. We can quickly copy this cable 3 more times with the command up here called mirror. First around the XZ plane and then these 2 around the YZ plane. Then we need also some supports, which will be hinged ones on each node. Now that we have our structure, we can move on to the loads and load combinations. First, we will stay with one load case, which will be the self-weight. What's important here is to set as action category form finding, and activate the self-weight and enter as Z1. Then we will select all 4 cables, and with double click we can open up the edit member dialog. Since we've already activated RF form finding in the general data, we can open up a new dialog by clicking on edit member type. Otherwise we wouldn't see this option here. And what can we define here? So we have the cable parameters for form finding. We can specify these via geometry or force. We can set a target cable length or a target cable absolute sag. For our example, we will define an absolute sag of 0.08, and the other parameters are filled in automatically, as we can see here. Next step will be defining the calculation parameters, which we can find under Calculate. And in this dialog, we have the tab Form Finding. Here we will set a maximum number of iterations, 50, and the speed of convergence will be 0.1 to get more precise results. And now that we have our load cases and also settings, we can run the calculation and then we can have a look at the deformation of the structure. As a second example, we will apply a wind load of 2 kilonewtons at the top and calculate the system again. What we can see with these results is while the 2 compressed cables do not absorb any load, the other 2 cables have a normal force like it should be. It's also interesting to have a look at the calculation diagrams. For this, we go back to the dialog of the calculation parameters. In the last step, we can have a look at the calculation diagrams. Here we can see why the calculation according to the theory of third order takes longer and how the calculation approaches the final results with each iteration step. And with that said, thank you for watching. In the next tutorial, we will go over surface structures like plates or slabs.